Hello everyone and welcome back to this new video of Agentic AI series. Today we are talking about agentic frameworks. In previous videos, we built the foundation of agentic AI systems. We explored the core components, models, memory, orchestration, and tools. At this point, we understand how these systems work conceptually, but now comes the more practical question. How are these systems actually built in real world? Because in practice, engineers, developers are not assembling these components from scratch every time, as we were trying to explain during the core components videos. Instead, they rely on frameworks, and more specifically, on framework ecosystems that enables all of these elements to be assembled together. A common mistake is to think in this way. I will pick a model, then a memory systems, and this abstraction tool, and so on. But this is not how most real systems are built in real world. Frameworks bundle these layers together into coherent systems. They provide abstractions, integrations, patterns that defines how everything connects within a real world system. So when we choose a framework, we are not just choosing a tool or a library. Actually, we are choosing the way of building the intelligence itself. We are choosing how the system will think, coordinate, and evolve. In reality, it's how the memory system will look like, how the agents should behave, how decisions should be made, etc. So all of these elements are assumed or encoded within the framework itself. So some frameworks, for example, will assume structure and control. Others will assume autonomy and emergence. The goal here in this video is not to go through the components of each framework or the features of each framework, but instead to have an overview of the frameworks and introduce different philosophies behind each of these ecosystems. So we will be able to choose which framework for which use case that we have ahead of us. Today, we will focus our overview on six major ecosystems that we could see in the market today, covering LangChain, CrewAI, AutoGen, LlamaIndex, Semantic Kernel, and Haystack. Each of these systems spans multiple layers, but in very different ways, and we will see in our overview the core idea behind the system, the strengths, some typical use cases, and the trade-offs. And finally, we will look at some kind of comparison and what framework or which framework to choose for which use cases. To start with, we are picking LangChain, one of the most commonly used or probably the most widely used framework in the ecosystem in agentic AI. Its core idea is simple but powerful. Systems are built as composable components. You can create chains, which are sequence of steps. You can create agents, which decide dynamically what to do. And with LangGraph, you can even build stateful workflows with loops, branching, and so on. LangChain tries to cover everything in its ecosystem. So it connects to models, tools, vector databases, APIs, and external systems. So it acts as a unifying layer across the entire stack of agentic AI. In terms of real-world usage, LangChain is often used for AI copilots inside applications, customer support systems that combine retrieval and actions, multi-step workflows where agentic or where the system needs to reason, retrieve data, and act. But this flexibility always comes at a cost. As the system grows, complexity increases quickly, and we need a strong architectural discipline here to keep things maintainable and under control. Because LangChain gives us power, this power always comes with responsibility. On the other hand, CrewAI takes everything in a very different approach. Instead of thinking in terms of chains or graphs, it thinks in terms of teams. Agents are not generic, they have roles. For example, a researcher, an analyst, a writer. So every agent has a goal and responsibility within the whole system that we are building, and tasks are explicitly designed and assigned to agents, and collaboration is well structured. This makes the system much easier to reason about, and we can map it directly to how human teams operate in a real business environment. In practice, CrewAI is used in marketing pipelines where one agent researches, another writes, and another reviews, or business intelligence workflows that transform data into insights, or sales automation systems that analyze leads and generate outreach plans or strategies to those leads. The advantage here is clarity, but the trade-off is flexibility. We are working within a well-structured system, which may limit more complex or unconventional workflows, which our business environments usually uh, brings in, and it's not fully designed in very structured, well-defined business processes. LlamaIndex shifts the focus entirely. The core idea here is that intelligence comes from data, and it provides advanced indexing and retrieval mechanisms. It connects structured and unstructured data sources. It excels at building RAG systems where we have corpus of documents or knowledge sources that we will use in our intelligent systems. In real business environments, it's widely used for enterprise knowledge assistance, financial and legal document analysis, and data aware copilots. Its strength is deep integration with data, but its limitation is orchestration. It's not designed to manage complex multiple agent systems. AutoGen introduces another perspective. Systems here are conversations, and agents interact through a dialogue. They exchange messages, ask questions, and refine outputs together. Tool usage emerges from the interaction itself, and this makes AutoGen very powerful for multi-agent collaboration. So we can here simulate teams, debates, or iterative problem solving use cases. It's often used for coding assistants that debug step by step, research agents that explore ideas collaboratively, and systems that require iterative refinement. But this conversational approach introduces uncertainty, and it becomes harder to predict the behavior of the agents here. And debugging becomes almost impossible and very complex. Semantic kernel takes a more structured, engineering driven approach. It treats AI systems as planning engines. So here we can define skills, which are functions, and planners decide how to combine these skills to achieve one goal or objective. It also introduces a strong plugin system. This makes it very suitable for enterprise environment. Typical use cases for semantic kernel include AI copilots embedded within enterprise tools, workflow automations inside applications, structured business processes, and so on. The trade-off is complexity. It requires more setup and engineering effort, so it's less intuitive for rapid prototyping. Haystack is the last framework in our overview. It represents a different philosophy. It sees systems as pipelines, not as agents. And here it defines a sequence of components, and each step in that sequence will perform a specific function. This makes Haystack very reliable for production systems. It's commonly used in search systems, question answering platforms, and larger scale document retrieval. But it does not focus on autonomy, it prioritizes control and predictability over autonomy and agency. Now, if we step back a little bit, something important becomes clear. We will notice that these systems or these frameworks are not just tools, they represent different models of intelligence. They represent, for example, in the case of LangChain, it thinks in graph. In CrewAI, it thinks in teams. AutoGen thinks in conversations. LlamaIndex thinks in data. Semantic Kernel thinks in plans, and Haystack thinks in pipelines. So when we choose a framework, we are choosing a way to structure the intelligence itself here, rather than choosing a tool or a model. So if we look at this overview from the perspective of control versus autonomy, it's clear that the systems that or ecosystems that they provide control, we can think of Haystack and Semantic Kernel, whereas if we're looking for autonomy, we look at CrewAI and AutoGen. In terms of flexibility versus structure, the most flexible one, as we have seen, would be LangChain, while structured will be CrewAI. If we look at it from data versus agency, data first, LlamaIndex is the best one in that regard. While if we look at it from agent first perspective, we can see CrewAI and AutoGen emerge there. So to choose the right ecosystem, we need to understand our business use case. So if we are looking at general purpose systems, LangChain would be the best for such use cases. If we have structured workflows, CrewAI, multi-agent collaboration, AutoGen would be the best. If we have data-heavy systems, for sure we go for LlamaIndex. In case of enterprise integration, we go to Semantic Kernel. And if we're looking at production pipelines, we go for Haystack. I know that usually use cases are not kind of split in this kind of strict classification, but we can mix these ecosystems together, or we can pick the ecosystem that we want or that represents the core of our business use case as we move into real business environments. So the most important part is to match the framework with the system shape, with the core business use case that we have at hand. The takeaway is this: we are not assembling a system from neutral components. We are building inside an ecosystem that defines what is easy, what is difficult, and what is even possible. So the question is not which framework is the best. The real question is what kind of intelligence system we are trying to build, because the framework we choose will shape the answer for such question. And here, back to our roadmap, we today we talked about the frameworks and tools. This is just an overview of the ecosystems in the market, but is not a tutorial for each of them. We will build more tutorials for each of these ecosystems in the future, but for now we just covered as an overview. For the next, we will move to the agentic capabilities and we'll cover the rest of the roadmap. And as usual, thank you for your time and attention, and see you in the next video.